Hi, folks. One of the big things that we deal with in life is trying to dissolve one thing into another. Whether we're doing laundry or we're doing the dishes, very often we're just trying to figure out what's going to dissolve in what. This process is called solubility, and it's the ability of one substance to dissolve another. And some things totally dissolve and others don't. Sugar, water, Kool-Aid powder dissolves very well. Oil and water do not. When you make a great cup of coffee, the grounds stay in the filter paper, but a lot of the flavorings and the oils and the essences go right through and go into making that cup of coffee. So what factors affect solubility? The big rule in chemistry is this, and write this down, put a star around it. It is a big deal, and it says like dissolves like. And we're referring to the chemistry. We're referring to the bonding of something. For an example, let's say you're working out in the shop and your hands get greasy and you're dealing with greasy tools and you're dealing with greasy motor parts. You have to have the right kind of soap. You cannot just use water. Water will not take this off. You have to use the right kind of solvents on the car parts. You have to have the right kind of soap on your hands to totally clean that up. You have to have something that chemically will bond with that oil in order to remove it. And that is, you have to have something that is like it chemically. So what we mean is this: watery things that are polar or ionically bonded tend to dissolve watery or polar things. Oily solutions or oily stains tend to need things that are covalently bonded to dissolve them. You need soap to clean dishes. You can't just rinse all the bacon grease off with water. It won't work. And it comes down to chemistry. If you have a stain or a mess that is organic and covalently bonded, something that is non-polar, something that's oily, something that's greasy, you have to use a solvent that is also going to be covalent and honestly a little oily and greasy in order to get that off. If you have a mess that is polar or watery and it's a collection of salt products, you need a solvent that is also going to be ionically bonded or polar or watery and salt based. So it comes down to, again, that chemistry. Water is referred to very often as the universal solvent. And we know that's not true. If it was true, every time you took a bath, you'd only do that once and then you dissolve completely. But water's unique polar structure, the fact that the oxygen end is slightly electronegative, the hydrogen end slightly electropositive, means that it has the ability to dissolve more things than other compounds can dissolve. It can dissolve a lot of polar organics. This is the chemical structure of alcohol. And this has a slight polarity to the molecule because this alcohol molecule, the ethanol that we drink, this is polar. So water and alcohol are 100% miscible. One can totally dissolve in the other. Water is very good at dissolving things like rocks. Pictures here of the Grand Canyon. Now, does it happen quickly? Absolutely not. It takes millions of years to create a canyon like this, but it can because these are salty, rocky mineral products, not organics. If you have an organic stain, something that's grease and oil and fat, water is not good. So is water 100% useful to dissolve everything? No, it's not, but it dissolves more things than anything else out there, and that's why it is commonly referred to as a universal solvent, and we use it for bathing and washing cars and doing our dishes. Now let's talk about this concept of like dissolves like And if you truly understand it, you can become a laundry superhero. If you have an organic stain, you have to have the right organic solvent. So let's kind of go through some examples. If you have a greasy stain on a shirt or organic collar stains, you have to have a greasy or oily solvent to get that off. Now, I'm definitely not endorsing any product. I just picked some pictures of stuff that I found to give you some clues of what I'm talking about. You have to have a solvent that will dissolve the oil and the grease. And pre-washes that are kind of oily textured, they're the ones that are going to work. That you need oil to dissolve oil. And that's why these pre-washes work. And that's why they usually have to be applied prior to the wash to dissolve that oil and make them slightly more polar so that the soap and water will take them away. If you have protein stains, blood, meat juice, anything like that, well, proteins can be removed or attacked by enzymes. Enzymes are a catalyst that help interact with proteins. Now, a lot of standard laundry detergents are going to contain some enzymes, but if you have bad enzyme stains all the time, you have a child that's in football and comes home with bloody clothes all the time from interacting in football games, perhaps you need an enzyme pre-soak. Now, if you just throw the enzymes in with some sort of bleach, bleaches will kill the enzymes. So throwing the bleach and the enzymes in together, don't even bother. You're wasting your money, as the enzymes will be killed by the bleach and it doesn't do any good. So they should be a pre-soak. Let the enzymes do their job. Then you can wash as normal. Now, enzymes are going to be harsh on delicate skin because why? Enzymes attack proteins. What is made of proteins? Skin is made of proteins. So if you have someone in your family that has delicate skin, do not use enzymes and use baby laundry detergent. Baby laundry detergent does not have enzymes in it because of the fact that that is going to be hard on delicate skin. Normal laundry soap, normal laundry detergent is going to be good at removing some oil and grease. That's the purpose of soap. We'll talk about soap more next talk. But if you have a lot of oil and grease, you're going to need to employ those pre-washes. And we talked about this back when we were referring to the families on the periodic table. But if you want to whiten white garments, chlorine bleach is going to work just fine, but it's a group 17 halogen. Very, very strong chemically. If you want an all-color, safer bleach, use something from the group 16 on the periodic table, an oxygenating bleach. It's going to be much, much safer and more chemically gentle. All right, just a few household chemistry tips. And next time, we're going to talk about soap in more depth. See you then.